This is the last video on where does the electron go. This one is on what is called electron configuration, which many people see as shorthand for the Aufbau diagram. For the electron configuration, you just have to follow the Aufbau principle for the ground state, and we're still going to use the mnemonic that you learned for the Aufbau diagrams. So just to recall, you fill up the 1s, then the 2s, then the 2p followed by the 3s, 3p 4s, 3d 4p 5s, 4d 5p 6s, 4f 5d 6p 7s, etc., etc., etc. When you looked at iron, you were able to draw the Aufbau diagram following that mnemonic, and it looked like this. Remember that we filled the 4s before we started on the 3d. But as I keep claiming, I happen to be quite lazy, and so there must be an easier way to notate this rather than writing out the Aufbau diagram. And there is, and that's called the electron configuration. The electron configuration is basically an inventory of where the electrons are. You don't need Hund's rule because you're not concerned about the suborbitals per se. You don't need the Pauli principle because you're not looking at spin. You only need to use the Aufbau principle. So if we take a look at iron, we can see that we filled up the 1s first. We write 1s with a superscript 2. Then we did the 2s and we put 2 in there. The 2p, so we put 6 in there. Then the 3s, we put in another 2 electrons. For the 3p, we put in 6 electrons. Then we put in the 2 electrons into the 4s, and the last 6 electrons went into the 3d. So this would be the electron configuration. Now if you add up the superscripts, you get 26 electrons, and the sum of the superscripts must equal the number of electrons you have to place. Now this can also be written in this fashion, where you put all of the third energy level together, and this reminds you that the 4s2 are the valence electrons, that you have 2 valence electrons here. So let's take a look at tin, which has an atomic number of 50, so we have to place 50 electrons. We set up our mnemonic. We say we're going to do the 1s first, so we go 1s2, subtract the 2 electrons. Now we have 48 electrons left to place. We do 2s, so we go 2s2 because we can put 2 in there, subtract the 2 and get 46. Now we're going to go 2p followed by 3s. That's a total of 8 electrons. We can put 6 into the 2p, so we write 2p6. 2 into the 3s, that's 3s2. Subtract the 8 electrons, and now we have 36 electrons to place. Next, we're going to fill the 3p and the 4s. That's another 8 electrons. Write the 3p6, 4s2. Subtract the 8 electrons, now we're down to 28. We see that we're going to fill the 3d, 4p, 5s next. That's 18 electrons, and we have more than 18 electrons. So we can go 3d10, 4p6, 5s2, subtract 18 electrons, and we will have 12 electrons left to place. We look at the 4d electrons and the 5p electrons. That's a total of 16. We don't have 16 electrons to place, so we're going to place the first 10 in the 4d10. That leaves us with 2 electrons, so we're going to put 2 electrons in the 5p. That's 5p to the second. And now we have no electrons left to place. So using the electron configuration as we filled it up, this would be the configuration: 1s2, 2s2, 2p6, 3s2, 4p6, 5s2, 3d10, 4p6, 5s2, 4d10, 5p2. Add up the superscripts, you get 50 electrons, so we've got them all placed. And I would tend to write it like this, just because it shows me that I have 4 valence electrons, but either way is acceptable for an exam. So to review electron configuration, the electron configuration is an inventory of where the electrons go. You only need the Aufbau principle to get the ground state, and if you break the Aufbau principle, you're in the excited state. You're going to use the same mnemonic to know which orbital is filled in what order. And remember, when you add up the superscripts, the total should equal the number of electrons in the atom. That does it for where does the electron go. The next couple of lectures will show what happens when you try to get things out of the ground state. See you for the next set.